So she punched him.
Oh my heavens.
What, Stu?
I mean, that's what the 6-year-old told me.
I remember you told me she's like really skinny, but like really strong.
She is.
I'm not messing.
If you're one of her friends, good for you. If you're not, then
What?
Okay. Oh, there she is.
I'm not in the player chat. I'm still in the football chat.
can you turn off the light?
Actually not today because I don't have my iPad to hook
Yo,
through.
low-key, let me know.
And so I'm not actually going to use the projector. It dawned on me that I really didn't even need to hook that up because I can't. So I'll just have it and I would just be writing on the board.
Yay!
Hello, sorry it's taking me so long.
No problem.
All righty. And then I also got here and realized I don't have my iPad cord and my iPad's dead. So I'm just going to be writing on the board today. So we'll just roll with it. All righty. So the first thing we'll do is we will answer any homework questions that you have. Let's look at what homework we'll be turning in. I believe we have 6-1 through 6-4. Is that right?
Yeah.
Awesome. So 6-1 through 6-4 is going to be the homework we're turning in. And then also our 5 test. I'll go ahead and collect it. Awesome. If you did it online, that's great. And then I'll just go ahead and. All right. So we're 6-1. Why is it not in order? 1, 2, 3, 4.
Yeah.
Take it apart. Take it apart. We're putting it back together. So what happens is I start grading and I go, oh, they don't have it. And then I mark it all wrong. And then I, and then I end up finding it. So if you would put it in order for me, that I would much appreciate it. Okay. Are you turning the homework tomorrow?
Yes,
6-1 through 6-4?
Yes, I'm putting it back.
Oh, or do you have it?
Yes, this is it.
6-1 through 6-4.
Yeah, that's the
Perfect.
homework.
Test. Homework.
Okay, here's 5 that I didn't get to yet, and then
Awesome.
the test
Wait, did we do 6-4? Did we get homework 6-4?
Uh-huh. Okay. So there's corrections for that.
I'll turn that thing tomorrow. That one more article.
Okay. You need to wait and turn it in tomorrow, Easton?
I don't think so.
6-4?
Y'all hear this? Isn't it on?
Jesus.
Because you don't want to just get counted off for it, do you? You want to get it done and turn it in tomorrow?
They look
Hey,
cute.
And I'm not seeing notes. Why don't you have notes on there?
Really,
Okay, I'll
Back tomorrow. Don't make a bad grade just because you haven't done.
Okay, for the
Thank
this, I think it's the
you.
right way. So it's page 130, then it goes like higher. More.
Okay, so this is 1,
1 through 6.
huh?
That's 1 through 7, and this is.
Okay, do you have questions from that? Is that why you're hanging on to it? We're turning in 6-1 through 6-4. So
Well,
go
we
ahead.
did also. Because we're not.
Yes, we will. Okay, so I'll go ahead and hold on to this. That, and that. Alrighty.
Freaking out.
So let's go ahead and take a look at our 6-4 homework. Go ahead and look on page 351 and 352. Look and see if you have any questions on any of these. We had numbers 9 through 14 all. Sorry, I guess it would help if I was on. Okay, so from 6.3, we'll check that real quick. 9 through 14 all. All right, is that right? What page was that? 342 goes along with
And the ones that we need to go up on this page are 10, 12, 14. The other
Okay.
we checked ourselves.
All right, so 342. Looking at number 10, yes, we have enough because the diagonals bisect each other. Number 12, yes, we have enough because we know that the opposite angles are congruent, therefore we know the opposite angle would be 60. Number 14, we do not have enough there. Why?
Two sides are on them.
Oh, wow.
On 342, we're on 342, sorry guys.
Oh.
Page 342, number 14.
The sides are on them.
I have opposite sides that are unknown. They are not marked that they're parallel. They're not marked that they are congruent. I only have one pair of parallel sides and congruent sides. So I don't have enough information there.
Then can't you, with 610, it says if one pair of opposite sides of the quadrilateral are congruent and parallel, since they're both, it is. congruent.
Yes, I'm sorry. So since they did mark the sixes there. So yes, you're right. The answer is yes. Thank you. For some reason, they don't have it marked in my book and I'm just running through, not even paying attention because I was just looking for my parallel sides, my two pairs. So yes, parallel and congruent. So yes, you have enough information. Let's look at 16. What do we have? We had 9 through, we just had 9 through 14
And that's the only thing.
and then 17 through 19. Sorry, not having my, okay. So 17, we see opposite angles are congruent. So X is 70. Number 18, I know that corresponding sides are supplementary. So 2x, I mean, X is going to be 60. I guess you already checked 19 and found that X is 90. So we had 17 through 19, and then is that it? Okay, that's it for 6-3. Let's jump to 6-4. 351.
Yes, but those were all odds.
Okay, so we have 351 odds, and then what about 352?
Also all odds.
Also all odds, so we're good to go on that. Perfect. All right, so today we are going to be talking about trapezoids and kites. Trapezoids and kites. All right. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So notice, I hate not having my visual up here. So we have one pair of parallel sides, and those parallel sides are called bases. Now notice that sometimes you may see a trapezoid and it is drawn or it is written where my parallel sides are the top and bottom. Sometimes it may be turned on its side, and you have to look though to see which sides are the parallel sides. Okay. So whenever I'm looking at a trapezoid, it could look like that. I'm not the best at the drawing. That's why I like having my pictures in my book. Maybe you'll see it like that. Okay, so it could be on its side, but the main thing you're looking for is the arrows that are marking my parallel sides. Okay, these are called my bases. And if you want to call this base 1 and this base 2, or vice versa, it really doesn't matter. So again, this is a base and this is a base. Okay, so either way that it's turned, my bases are my parallel sides. The other sides are called legs. And so it says that if my legs are congruent, then this is called an isosceles trapezoid. So an isosceles, I-S-O-S-C-E-L-E-S, trapezoid has a pair of parallel bases and congruent legs. An isosceles trapezoid has a pair of parallel bases and congruent legs. So now there's a couple of things that when I'm dealing with an isosceles trapezoid, there's a couple of things that I know to be a fact, and these are our theorems right here, where it says, if a trapezoid is isosceles, then each pair of base angles is congruent. So what we'll do is, if it is an isosceles trapezoid, then base angles are congruent. That's the first thing I know. The second thing is, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. Okay, so I've got, if the base angles are congruent, then it's a trapezoid, and then it's an isosceles trapezoid. If it's an isosceles trapezoid, then the base angles are congruent. So I can go converse on those. And then theorem 616 says if a trapezoid is isosceles if and only if its diagonals are congruent. So its diagonals are congruent. Okay, so if it is an isosceles trapezoid, then its diagonals are congruent. Okay, so isosceles trapezoid. Now remember, we can have an isosceles trapezoid that would look like this, where maybe I've got a length like this, and I've got a length that would be like this. Okay, so remember, that would just be a regular trapezoid where I'd have my parallel bases, but these two legs are not congruent. So remember, I can have a regular trapezoid that my legs are not congruent, and I can have a trapezoid where the legs are congruent. If the legs are congruent, then I know base angles are also congruent, and I know diagonals are congruent, but that's only with an isosceles trapezoid. Okay? So if we look at example 1, it says using properties of isosceles trapezoids. In example 1, it says PQRS is an isosceles trapezoid. We need to find the measure of angle P, the measure of angle Q, and the measure of angle R. All right. So now one of the things to notice is, how many bases do I have? How many bases do I have in an isosceles trapezoid? 2 bases, right? So how many base angles does that mean I have? 4. Because I've got base angles here. So those will be congruent, and these are going to be congruent. Okay, so remember that when I'm dealing with base angles of an isosceles trapezoid, I've got 2 pairs of base angles. So when I'm looking at this example, in example 1, I can see that it's upside down. Let me go ahead and put it right here underneath. So they said this one is 50 degrees. So what do I know this angle is going to be? If this angle is 50 degrees, what is this angle going to be? 50 degrees. Now, how can I figure out these 2 angles down here? What do I know my total interior angle measure of a trapezoid is? Why do I know it's 360? Because what kind of shape is it? It's a quadrilateral. Remember, all quadrilaterals have interior angles that equal 360. A trapezoid is a quadrilateral. Therefore, my interior angles are 360. My base angles are congruent, so I know that this one's 50 degrees, this one's 50 degrees. So what do I know these 2 angles have to add together to equal?
130. Like they're not gonna have to add to that, but they're both.
Okay, let's think about angle 1, the measure of angle 1, plus the measure of angle 2, plus the measure of angle 3, plus the measure of angle 4 equals 360 degrees, right? What do I know? We'll call these angle 1 and 2. So we know we've got 50 degrees plus 50 degrees plus, I'm going to call this X and X because we know they're the same. So therefore, I've got 50 degrees plus 50 degrees is 100 degrees plus 2x is equal to 360 degrees. I need to subtract 100 degrees from each side. And I've got 2x is equal to 260 degrees. Therefore, what does each x equal? Well, not divided by x, divide by 2, divide by 2. So x is equal to 130 degrees. What would have been another way that I could have figured out that each measure is 130 degrees?
It's 360, so you could have just added 50 and 50.
Mhm.
If you did the math, you could have just seen it's 130 and 130.
Okay. And if you just do the math, you see it. What do I know that corresponding angles equal? 180. So what's 180 minus 50? 130. So also remembering, not only can I use that my 4 angles, my quadrilaterals add to equal 360 degrees and use it that way, add up 50 and 50, know that it's 100, subtract it from 360 and divide by 2. I also know that corresponding angles, because when we talked about quadrilaterals, we learned that corresponding angles are supplementary. So remember that our rules for quadrilaterals are still applying here because a trapezoid is a quadrilateral. Therefore, I can use those same rules, okay? All right, so let's go ahead and look at page 357. 357, example 2. It is saying to show that ABCD is a trapezoid. All right, so remember when we're dealing with a coordinate grid, we know that we have ordered pairs that give us points to be able to graph. Okay, so anytime I'm thinking coordinate grid, I'm thinking my X and Y values, I'm graphing points. I know that when I connect points, I'm making a line. I know that a line gives me a slope. Okay, what do I know about an isosceles trapezoid? What were our criteria for isosceles trapezoid? How many pairs of parallel sides do they have? One pair of parallel sides. And for a regular trapezoid, for an isosceles trapezoid, what do I know about the length of the legs? They're congruent. Good. Okay. Now, when I'm looking at this picture in 357, what do I have to prove about this figure to prove it is just a trapezoid? What is my main criteria for a trapezoid? That it has a pair of parallel sides. So when I'm looking at my figure, I can see here that I've got my parallel sides, I've got my bases. So I can calculate the slope of this side and the slope of this side. What do I know about the slopes of parallel lines? They're equal, they're congruent, they're the same. I know that parallel lines have the same slopes because then they never intersect. So if I wanted to prove that this is a trapezoid, then I need to look and find the slope of each of my parallel lines to compare and make sure that they are indeed parallel, okay? So that's what they've done here, is they have found the slope of AB and the slope of CD and found that they are both -1. Therefore, they are parallel. And then if you look at the slopes of BC and the slope of AD, okay, BC, we can see our slope is 1/2. We can see AD, our slope is 2. So we know that those are not parallel. So since they are not equal, they are not parallel, but we know that because I do have one pair of parallel sides, that this is a trapezoid. Does that make sense? Remember, if you have not memorized slope formula, go ahead and put that in your brain right now. M is equal to y2 minus y1 over x2 minus x1. Remember that when I'm dealing with slope, my y values are in the numerator, x values are in the denominator. All right, now we're getting into the mid segment of a trapezoid. So, quick little review. How would I name this? What kind of figure is this?
Triangle.
Triangle. I know two sides are congruent, therefore it is. What do we call it if three sides are congruent? Equilateral. Two sides congruent. Isosceles, no sides congruent. Scalene, good. So this is an isosceles triangle, right? And what did we learn about the mid segment of an isosceles triangle? It is half of the base. So with my mid segment of a triangle, of an isosceles triangle, my mid segment is equal to half of the base. In this situation, we have a different shape, right? So we'll put isosceles, isosceles, sorry, triangle, midpoint equals 1/2 base. Okay. Now, when we're looking at our isosceles trapezoid, and I'm looking at the midpoint, okay? This is base 1, it can 2, it really doesn't matter. This is base 2. My formula for a midpoint here, this is an ISOS, an isosceles trapezoid, midpoint equals, now in this situation, for my mid segment, I have got to take 1/2 of base 1 plus base 2. So basically, I'm doing the average of the bases. I have to add my two bases together and multiply by 1/2, which is the same as. Okay. We're doing here with our isosceles trapezoid. Bases together and divide by 2. I find the average two bases. And that's what we can see in our theorem 16, mid-segment theorem for trapezoids. The mid-segment of a trapezoid is length is 1/2 the sum of the lengths of the bases. Look at example 3. If you had a person baking a cake and they know that they want their bottom layer to be 20 inches and the top to be 8, then they want to figure out what size should that middle layer be. So basically 8 plus 20 is 28 divided by 2, 14. So I know that middle section would be a 14-inch round layer. Okay, so we can see how, if any of you want to be bakers one day, then you can see how you can use the mid-segment theorem of isosceles trapezoids to figure out your shapes and your measurements. Everyday geometry. Okay, go ahead and turn to page 358. Yes. You can walk to the bathroom. Just kidding. Run. No, I'm kidding. All right. Now we're talking about a kite. On page 358, we're dealing with kites. All righty. So this is page 358. I'm talking about a kite. And we can see by our picture, it's going to be something kind of like that. And we can see they've done that and that. So by this diagram, what am I able to tell immediately? Looking at just the hash marks, what do I know? I have two pairs of congruent sides. Okay, so a kite has two pairs of congruent sides. Now, one of the things to add in there is we'll write the word consecutive because they are side by side. Okay, remember the word consecutive means side by side. So my top sides are congruent and my bottom sides are congruent. Two pairs of consecutive congruent sides. Now, when we look at our theorems about kites, it says if a quadrilateral is a kite, then its diagonals are perpendicular. So its diagonals are perpendicular. So notice if I were to add my diagonals here, that's where I'm going across and I'm going from point to point or from vertex to vertex. And notice that when I put my diagonals in of a kite, they intersect at a 90-degree angle, which is our definition of perpendicular. And it says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So one pair of opposite angles are congruent. All right, so for a kite, has two pairs of consecutive congruent sides. The diagonals are perpendicular. They have one pair of opposite angles that are congruent. So let's look at example 4. It says the diagonals of a kite. So it says WA is a kite, so the diagonals are perpendicular. You can use Pythagorean theorem to find side lengths. Remember, when can I use Pythagorean on what type of shape? Right triangle. Pythagorean theorem, T-H-R-E-M. Use only with right triangles. And you can have a squared plus b squared equals c squared, or you can write it as c squared equals a squared plus b squared. It doesn't matter which you start with. Some people like to start with that c squared equals a squared plus b squared, because then you've got your variable that you're solving for. If you're solving for c, is on the left-hand side. It just depends on what side you're solving for. What are the main things I have to remember about using Pythagorean theorem? What in my equation is the have to position? A, B, or C? Does it matter which side is A?
No.
Does it matter which side is B?
No.
Does it matter which side is C?
Yes.
Why?
Because you're solving for that. If you switch up A and C, then you will get the right answer.
Okay. What if I had something that looked like this? I'm just going to make up numbers. I don't even know if they're going to work. Does it matter which one of these I call A? Does it matter which one I call B? Does it matter which one I call C?
Yes.
Why? Where does C have to be in a triangle for Pythagorean theorem? Has to be the side opposite the 90-degree angle, which is my hypotenuse. Okay. The only thing that has to be C is that one. It really doesn't matter if I pick one of these as A or B. Okay. What does matter is that the hypotenuse is C. So hypotenuse must be C. Side, I'll put side C. Okay. So notice when I've got a kite, how many triangles do I have? 4. How many right triangles do I have?
2.
4. Because remember, if they're perpendicular, that means this is a 90-degree angle, this is a 90-degree angle, this is 90, and this is 90. So I could figure out my sides of all of them using Pythagorean theorem if I have enough information. So when we look at this example, I see that I have I can see that from W, Y, I have a measure 12, and then from X, Z, I have 12 and 12. Remember, I've got one pair. That doesn't matter. So basically, if I'm looking from W to X, notice I've got 20 and 12. I guess it's going to be best to draw it. Of course, I drew it backwards. I don't know. so we said W X Y Z 20, 12, 12, and 12. Okay, so I can see here, I need to bring my colored markers if I'm gonna be writing on the board. I can see here that I can need to try to find this side, which is opposite the right angle. I can see here that I could find this side. I could find this side based on here. I could use 20 and 12 in my Pythagorean theorem. For this side, I've got 12 and 12. So I'm looking for this side, same thing, 12 and 12 is here. But remember, I would only have to do 2 calculations because I know that I've got 2 pairs of congruent sides. So as long as I found the length for one, for c squared is equal to the square root of a squared plus b squared. Just remember that when you use Pythagorean theorem, you're solving for c, not c squared. So you have to take the square root of both sides to solve for the single variable. All right, let's look at example 5, the angles of a kite. It says find the measure of G and the measure of J in the diagram at the right. So think about what are my interior angles of a quadrilateral equal to? All quadrilaterals, 360. What measures do I know? 132 and 60. What do I know about J and G? They're congruent, therefore I can take 360 minus 132 minus 60, and I see that I've got 84 left, and I divide by 2. No, I don't. I've got 168 left, and I divide by 2, and that gives me 84. Since I know that those are congruent angles, I know they're each going to be 84. All right, that's the bell for our break. So go ahead and take a break, and we will come back.
Has there been a lot of people here today? I mean, I know there's only probably one class before this one.
I don't know. I mean, I just got here for this class and I haven't, I mean, it seems kind of quiet.
It does, doesn't it?
Yeah. Are you missing many or is it just, well, and I also know that they're taking a test. So I think they've been real quiet
Yeah.
in Mr. Perry's class, but I don't know. Have you had many out?
Not on Monday. Today I
Yeah.
had two so far,
Okay.
but one of them.
Oh. Yeah. Yeah, so that makes a huge difference. That's how pre-algebra class is. I only have 5 in the class and 1 who's every day.
Yeah.
So I only have 4 that are usually in class.
Yeah.
So I think yesterday I had 1 that was home that Zoomed and then 1 that I never saw. And so I only had 2 kids in class. For 2, and they, I mean, they're. I know. So,
Yeah. Draw Shrek. Draw Shrek on the whiteboard, but she came back.
You could have. I would have just been like,
Something.
it's not over. It's not over. Not over.
You're what, like, okay, you can teach it now.
I'll teach them all about Shrek. dude.
That's how teacher Garrett started.
Shrek is one of those.
you have a lot of Shrek knowledge. All righty. So let's go ahead and take a look.
Water, Luke, so don't forget having them seed.
Okay,
You're ready to learn.
you ready to learn now?
Yeah.
All right, you got a sip of water.
Thinking cap is on.
All right.
Shrek.
Yeah. Okay, so let's go ahead and look at page 359. All right, so 359, let's look at guided practice. Look at the first one. It says name the bases of trapezoid ABCD. How do I know which side are my bases?
The bottom and top.
Is it necessarily, it is in this one, but why do you know it's the bottom and top of this one? What is drawn on your figure? The arrows indicating that they are parallel. Good. Parallel sides are my bases. Okay, it says explain why a rhombus is not a kite. What is a rhombus? A quadrilateral with 4 congruent sides. Good. So a rhombus has 4 congruent sides. How many congruent sides does a kite have? 2 pairs of congruent sides. Okay, so the difference between a rhombus and a kite is my rhombus has 4 congruent sides. Look at the next ones. It says identified as a trapezoid, an isosceles trapezoid, a kite, or none of these. Look at number 3. What do I have?
Two pairs of congruent sides.
So is it a trapezoid, isosceles trapezoid, a kite, or none?
A kite.
Too much
You just
for
said that.
geometry.
Oh, what? What?
Okay. Does a kite have parallel sides?
2 pairs.
No. They have 2 pairs of congruent sides. Congruent and parallel, different things. Remember, parallel means that they're never going to intersect. Okay, so if I look at a kite, my lines both intersect. Okay, so number 3, I've got a pair of parallel legs, I mean a pair of parallel sides or bases, and I have 2 congruent legs. So what kind of shape do I have?
Isosceles trapezoid.
Isosceles trapezoid. What about number 4? What is that, Easton?
None of these.
No, it is number 4.
None of these.
What do I have in that figure in number 4?
None of these.
I have two pairs of congruent sides. What has two pairs of consecutive congruent sides?
Okay.
A kite. Good. Look at number 5. What do I know from this figure? What do I have? I have 2 right angles. What else do I have?
2 parallel sides.
2 parallel sides. So what kind of shape is it? They're killing me, Keely. They're killing me. It's a trapezoid. Good. All right.
What's number 3?
Number 3 was an isosceles trapezoid. Number 4 is a kite. And number 5 is a trapezoid. All righty. Look at number 6. It says, how can you prove that ABCD in example 2 is isosceles? What would I have to do to prove that ABCD is isosceles? What would I have to prove about AD and BC? That they were congruent.
base angles are
I would have to show, not base angles, I'm talking about sides here, okay? Remember, sides and angles, I've got to look at my notation to know what's different. So if I'm looking at that and I can see that it's a trapezoid, then for it to be an isosceles trapezoid, I have to show that my 2 sides are congruent, okay? What do I use to show that sides would be congruent? What formula would I have to use? If I'm showing the length of 2 sides are congruent, I could use coordinate grid and I could use the distance formula, okay? All right, let's look at number 7. Find the length of the mid-segment. What is my formula for finding the mid-segment of a trapezoid?
Wouldn't you add 7 and 11 and then divide that by 2 and you get 9?
Very good. Add your bases, divide by 2. So 7 plus 11 is 18, divided by 2 is 9. Look at number 8. What are my base measurements?
7 and 3.
Divided by 2? Good. So my mid-segment is 5. Look at number 9. What measures are my bases? How can I figure out my bases?
17 and 12.
7 and 12. Okay, so 7 and 12 is what?
19.
19, and 19 divided by 2 is? What's half of 19?
8,
10, 9.
9 and a
9.5.
half.
Good. It's an odd number, so I know I'm going to have something 0.5. All righty. Yes,
What about the 2 5s? Like, are those just there just to throw you off? or-
they're just there to see if you can identify which information you need to know. Sometimes a problem may give you too much information, and you've got to find out, you've got to be able to decipher what information is pertinent to the problem, okay?
What was number 8?
Number 8, our bases are 7 and 3. So 7 plus 3 is 10. 10 divided by 2 is 5. So my mid-segment is 5. All right, so homework. Let's go ahead and take a look. Page 359. We will do numbers 16 through 21, all. Now, this we will just check in class tomorrow.
So do it today.
Tomorrow.
Wait, what is the homework?
Okay.
Page 359.
Page 359, numbers 16 through 21. We're going to look at that tomorrow and then go ahead and turn over to page 360, 22 through 24, 22 through 24, and then 28 through 33. We may actually have some time at the end of class to work on this in class. So,
Wait, is this all for all?
I would like you to try to get them done for tomorrow.
Are they
Okay.
odds? All odds?
All. They're both all. Okay, so really that's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 problems, but more than likely, you can just look at these and immediately get an answer. Okay, it shouldn't take too long.
We should spend the last hour doing this.
Now let's go ahead and take a look at 6.6, special quadrilaterals. 6.6, special quadrilaterals. can see here that they have drawn kind of a quadrilateral tree, if you will, where they've got the quadrilateral at the top. And so think about, what do we know about quadrilaterals? How many sides do they have? 4 sides. What do we know the interior angles measure? Interior angles measure 360 degrees. Okay. So now, types of quadrilaterals that we've looked at. We have talked about a kite. We've talked about a parallelogram. And we've talked about a trapezoid. What are my things about kites?
2 pairs of
2 pairs of consecutive, congruent sides. What else? 2 pairs of consecutive congruent sides, and opposite angles are, it has pair of opposite angles that are congruent, right? What about parallelogram? What do I know about parallelogram? It has 2 pairs of what? Look back if you need to. That was in section 6.2. 6.2, properties of parallelograms. 2 pairs of what? Look back at page 330.
opposite sides.
2 pairs of of parallel sides. We'll say of opposite parallel sides. What else about a parallelogram? What do we know about opposite angles? Opposite angles are congruent. They bisect each other. Good. Diagonals bisect each other. Another thing that I know is that consecutive sides or consecutive angles equal 180 degrees. What do I know about a trapezoid? As one, or we'll just say bases are what? Parallel. And that's the only thing I know for sure about the trapezoid, right? That's the only thing. Now, if it was an isosceles trapezoid, that'd be one thing, but for just a basic trapezoid. All right, so now notice, flipping back to our chart, when we talked about a parallelogram, I'm gonna come down this way, because we talked about, for our parallelograms, we had a rhombus and a rectangle. What is my rule about a rhombus?
4 congruent sides.
4 congruent sides. What is my rule about a rectangle? Opposite sides are congruent. 4 right angles. Okay. What shape is a rhombus and a rectangle?
A square.
A square. So the main thing in looking at this is I can see, so my top starts with a quadrilateral. So I know that a kite, a parallelogram, and a trapezoid all have these same properties, okay? They have 4 sides, interior angles are 360. But if it's a kite, it has these specific things about it, Okay, so it has this information as well as this information. If it's a parallelogram, it has this information and this information. If it's a trapezoid, it has this information and this information. But when I go off of a parallelogram, I've got a rhombus and a rectangle. So if it is a rhombus, it is also a parallelogram. And if it's a parallelogram, it's a quadrilateral. So it has all of the traits of all of them. Same thing with rectangle. If it's a rectangle, it has the same traits as a parallelogram, same traits as a quadrilateral. A square has the traits of a rhombus and a rectangle, parallelogram, quadrilateral. So you can kind of see how these shapes, that's what this tree
Ultimate.
is showing us. Okay. So if we look at it, and we can see here that we have a parallelogram, a rhombus, a rectangle, a square, and an isosceles trapezoid. We can see all the different ways that we can tell these different quadrilaterals are different from one another. Okay. Now, one of the things when we talk about, let's go ahead and jump over to example 3. It says proving a quadrilateral is a rhombus. What do I know? What is my main thing about a rhombus? What was my key thing that we listed up here about a rhombus? 4 congruent sides. Okay. So if I look at the grid, if I look at the picture that is graphed there, what would I have to tell that each side is equal to? The same thing, right? And like I said, when I'm finding distance, so I've got to look at what is my distance from L to K? What is my distance from K to N? What is my distance from M to N? What is my distance from L to M? So notice that they set up 4 different distance problems. What is my distance formula? D is equal to the square root of, distance is equal to the square root of, anyone? Euler?
X2.
Are y'all ready for me to blow your mind blown? To the back flap of your book.
Wait, what?
The back of your book. The hard part. You got skunked. Must be somewhere. This is actually a huh. How about that? Okay. And then I have a distance formula there.
That's so fast. You already messed it up.
Let's find where y'all's is in this book.
Front. Now I see.
And they need a hug.
Yeah.
You look like you need a hug.
I'll do it.
We're already like halfway.
Okay, so if it's not in the back of your book, go ahead. Well, first of all, let's see. In your book, turn to page 827. 827. What you got here?
Postulate.
Postulates. Here's our whole list of postulates. Turn the page. What's the next page? Next page is theorems. Okay, so here's a whole complete list of postulates and theorems from our textbook. So if your book does not have your mathematics reference sheet in the back, you can also go to the glossary in your textbook, which is basically like a dictionary of your textbook, and look up the distance formula. So in your glossary, distance formula. Okay, so what is my distance formula? Now notice they say AB because they're talking about the measure of a side. I'm just going to put D for distance. D equals the square root of, what is it?
X2 squared.
X1 plus
Oh, it was
x2 squared.
Minus, you're right.
What? It is minus because I'm gonna have, then I have plus in the middle. Y2.
It's supposed to be x2 before x1.
Okay, so here's my thing, okay?
Yeah.
Whether it's x1 or x2 is not gonna matter. So let's look at this for a minute. Let's say I have a point that is, let's see, let's go ahead and do -2, 3, and then a point which is 2, 5, okay? We'll say that this one is x1, y1, x2, y2. Okay, I'm just using two of our points from this example. This is point L and point K. All right, so we're going to do it this way first and have distance is equal to the square root of x1, which is -2, minus x2, which is 2, squared, plus y1, which is 3, minus y2, which is 5, squared. All I've done is plug in my values. So distance is equal to the square root of -2 minus 2 is what?
-4.
-4 in parentheses squared, plus 3 minus 5 is
-2.
-2 in parentheses squared. So distance is equal to, what is -4 squared?
8.
No,
+8.
no.
16.
What?
Remember, -4 squared
Okay,
is
okay.
-4 times -4. So that is going to be positive 16 plus, what is -2 squared?
4.
Positive 4. So distance is equal to, what is 16 plus 4? 20.
Dude,
Now,
all I saw was 4 and 2, and I was like, 8. I was like,
here's the deal. In geometry, they are not making you simplify my radical. Okay?
Yes,
How do you simplify radicals? What do you have to do first?
the buddy system.
You have to list out prime factors. You've got to pull out your buddies, all that good stuff. Okay. But in geometry, they're not making you simplify. They're just saying, hey, what is it? Now let's look at it. If we had reversed this and we have distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So now all we're doing is flip-flopping our x2, x1. Here we had x1, x2. So distance is equal to the square root of x2 was 2 minus x1 is -2 squared plus y2 is 5 minus y1 is 3 squared. Distance is equal to, what is 2 minus a -2?
0.
No, 2 minus a -2. If I have minus a negative, what is that the same? It's plus a positive, so that's going to be 4 squared plus, what's 5 minus 3? 2 squared. What is 4 squared? 16. 2 squared is 4. It does not matter. Do not get hung up on which one's x1, x2. What I want you to memorize is distance is equal to the square root of the difference of the x's squared plus the difference of the y's squared. It doesn't matter my order of x's or the order of y's. What does matter is that I'm finding the distance of the x's squared plus the difference of the y's squared. Okay, so don't get hung up, because then you start going, well, how do I know that this is 0.1 and this is 0.2? What if this is 0.1 and this is 0.2? That used to freak me out. That's why I used to think it was magic, because I was like, how in the whole wide world am I supposed to know which one is 0.1 and which one's 0.2? It doesn't matter. Okay, what does matter is that you find the difference of the x values and square it and add it to the difference of the y values and square it. You're going to get the same answer. Okay. So distance formula is something that you need to memorize. Okay. What I recommend is every time you work a problem dealing with the distance formula, write your blank formula out. The more times you write that blank formula, d equals the square root of, and you'll find if you have a preference of x2 minus x1 or whatever, write your equation every single time you work a problem like that, and you're going to memorize it just like that, because the more you write it, the more you remember it. Okay, so in example 3, they used the distance formula for each of my sides. They found that they are all equal to the square root of 20. Therefore, they are all congruent. Therefore, it is a rhombus. Let's turn to page 366. 366. What kind of shape do I have in 366?
Which one?
Page 366, example 4.
A triangle that was cut off like a chip.
Okay, so I have a broken Dorito. It is a quadrilateral. It has 4 sides. Okay, so it has 4 sides. What do I know about my opposite angles? What do I know about my base angles? Angles.
Base angles are congruent.
Base angles are congruent. You can see that from I got A and B are both 60 degrees and D and C are 120. So therefore, what kind of shape do I have if I know my base angles are congruent? If I have 2 pairs of congruent base angles, what kind of shape do I have? It's a trapezoid. What kind specifically of a trapezoid? Isosceles trapezoid. Remember, isosceles trapezoid, one of the rules we talked about earlier was that it has 2 pairs of base angles that are congruent. So my angles at the top are congruent, my angles at the bottom are congruent. Okay, therefore I know it is an isosceles trapezoid. All righty, let's go ahead and look at example 5. I've got diagonals here. And what do I know about my diagonals? They're all congruent. So what kind of shapes have congruent diagonals? No.
Yes, they do.
Isosceles trapezoids do, yeah. So we can see here that this is going to be, we've got a rectangle, okay? So why, let's go ahead and flip on, we're going to jump over this section. Actually, Yeah.
Got me over?
No.
crazy. Real quick, look at page 368 for a minute.
Oh.
No.
368. Look at number 16. It says identify the special quadrilateral and use the most specific name. What do I have in number 16? What do I know? I have 2 angles. They are congruent. And what kind of angles are they? They're right angles. So think about if I have 2 right angles that are opposite each other, what do I know about those sides? They're probably parallel. Good. And if I have a pair of parallel sides, what kind of shape do I have? What type of shape has a pair of parallel sides? Nope. A parallelogram has 2 pairs of parallel sides. If I'm looking at that shape, do I have 2 pairs of parallel sides? Nope, because I can see one is clearly slanted. Trapezoid. Good. Number 17. What information do I know from this shape?
That one side is a right angle, but the other one is not.
Okay. So what do I know about my hash marks? What are they telling me? All sides are congruent. What kind of shape is this? It's a square. Okay. Remember that corresponding sides are supplementary. What does that mean? If corresponding sides are supplementary, what does supplementary mean? That they equal 180 degrees. If one side is 90 degrees, what do I know its consecutive angle is? 90 degrees, because if they have to add together to make 180, I know that each angle in that shape is a 90-degree angle. If it's a 90-degree angle, if all sides are congruent and all angles are congruent, that is a square. I say all angles are congruent. If all angles are congruent and they're 90-degree angles, they're all right angles. Let's look at number 18. What do my hash marks tell me?
Congruent.
Okay, how many pairs of congruent sides do I have? 2 pairs of congruent sides. When we drew our little diagram, what did we find out about a shape that has 2 pairs of consecutive congruent sides? No. Consecutive means what? It's going to be a kite because consecutive means side by side. 2 pairs of consecutive congruent sides makes a kite. Okay. So you may want to, all these new terms and all these new properties of each shape, you're going to want to study these. You're going to want to learn what makes them different from each other.
They go in the blue folder.
These would be blue folder items, absolutely. Look at number 19. 19, how many sides does it have? 4, so it is a quadrilateral, right? Okay, what do I know about the opposite angles? They are congruent. What types of quadrilaterals have congruent opposite angles? What types of shapes? Think about our tree that we drew a minute ago. Flip back to that for a second. Flip back to page 364. Which shape listed under example 1 says opposite sides are congruent?
Parallelogram.
Okay, so parallelogram,
Rectangle.
a rectangle. Notice if all they told me in number 19 is that opposite sides are congruent, it could be a parallelogram, it could be a rectangle, it could be a rhombus, it could be a square, and it could be a kite. All of those have that trait. Look at number 20. I've got consecutive sides are congruent. So it could be a rectangle, could be a square, could be isosceles trapezoid. Okay, so when we're looking at our shapes, we have to go based on what is the information they have specifically told us. Let's jump down to number 30. Look at number 30. What do I know the measure of angle C is?
70.
What is my rule about trapezoids? Base angles are trapezoids. Base angles are congruent of an isosceles trapezoid. So and it tells me in number 30, this is an isosceles trapezoid. Therefore, what is angle C?
70 degrees.
110. Base angles are congruent. These 2 angles are the same. These 2 angles are the same. So C is 110. What is angle D? 70 degrees. They told me it's an isosceles trapezoid. I know that isosceles trapezoids have base angles that are congruent. Therefore, if B is 110, C is 110. If A is 70, D is 70. All right, now let's go ahead and move on to 6-7 on page 372. All right, so page 372, we are starting with areas of triangles and quadrilaterals. What we're going to do is we're going to go ahead and write all of these angle formulas. So area of triangles and quadrilaterals. Okay, so it says area postulates. We know that the area of a square, what do we know about a square? All sides are congruent. So a square area is equal to side squared. I take the measure of each side, or I take the measure of one side since they're all congruent, and I multiply side times side. That's my area formula for a square. Remember, if a polygon is congruent, then the two polygons are congruent, they're going to have the same area. The area addition postulate just says that the area of a region is the sum of the areas of its non-overlapping parts. We're going to look at that in just a little bit when I have some shapes that can be broken into multiple shapes. Now let's look at the area of a rectangle. This should be something that you already know. What is my formula for the area of a rectangle? Area equals, you should be writing these down. Area equals what? Area of a rectangle. BH. What does B mean?
Base.
What does H mean? B equals base. H equals height. Base times height. What about a parallelogram? What is my formula? A equals
Lowercase b.
BH. Again, look at the difference between my rectangle and my parallelogram. With my parallelogram, notice that my height has a line that's coming down from a vertex to a base at a 90-degree angle. Anytime I have a formula that involves height, I know that the height of a figure has got to intersect at a 90-degree angle. Therefore, I'm going to usually see that dotted line where it's coming down through the shape. All right, what about a triangle? Area equals
1/2 base times height.
1/2 base times height. Why do we cut it in half? Otherwise, it would be a square, it would be a rectangle, right? Okay, so think about, we said that if I have a rectangle or even a parallelogram, and I cut it in half, I've got two triangles. Or if I have a parallelogram, cut it in half, I've got two triangles. Since a triangle is half of a rectangle or a parallelogram, my formula is area equals 1/2 base times height. Again, when I'm looking for the height of a figure, I am looking for top to bottom coming down and intersecting, that it's perpendicular, therefore it intersects at a 90-degree angle, okay? Go ahead and turn over to page 374. We're going to look at the area of a trapezoid. Area equals, look at our formula here. Area of a trapezoid. What is my formula? 1/2 H, 1/2 of the height, times base 1 plus base 2. So if I'm looking at a trapezoid, I have my height here. This is a base. This is a base. So I'm going to multiply 1/2 times the height times base 1 plus base 2. Add your bases together, divide by 2, multiply by the height. Take half of the height, multiply it by the bases added together, however you want to do that. Area of a kite. What is my formula? A equals 1/2 D1 times D2. What does D stand for?
Distance.
Look at that formula on page 374.
Diagonal.
D equals diagonals. So for my kite, I'm looking at the distance of diagonal 1 times the distance of diagonal 2. So diagonal 1 times diagonal 2. And then multiply it by 1/2 or divide by 2. Okay, remember, multiplying by 1/2 is the same as dividing by 2. Everybody good with that? All right, what is my formula for a rhombus?
Same thing.
Same thing. Area equals 1/2 D1 times D2. These are my formulas for area. Okay? These are my formulas for area that I need to know. You should already know at least square, rectangle, parallelogram, and triangle. Probably your new ones are trapezoid, kite, and rhombus. Okay? And I think what I'm going to do is I'm going to go ahead and give an assignment, except what we're going to do is we're going to do all the work in class tomorrow. So the assignment that I gave you guys a little bit earlier that you hopefully wrote down, we will start with that in class tomorrow. So you don't have any homework tonight. Okay? But let's look at what we're going to be doing tomorrow. So,
I already did it.
awesome. Then you'll be well ahead. Okay. So we had written that down. Let's see, we said it was page 359.
16 to 33.
Numbers 16 through what?
233.
We had
I thought it was
16.
21.
I know, but
Well, we had 16, basically pages 359 to 360. We have 16 through 24. So 359 to 360 is 16 through 24. And then we have numbers 28 through 33. All right. And now we're going to come over and we're going to go to page 376 and 377. And we will have numbers 14 through 28.
we'll do that tomorrow.
Uh-huh. And numbers 35 through 38. Actually, 35 through 38. And we'll do 41 through 43. 41 through 43. So that'll be 376 to 378. This is what we will do in class tomorrow. Okay, this will wrap up chapter 6. We're going to be doing pages 359 through 360, numbers 16 through 24,
doing all of
28 through
them?
33, all. We'll be doing 376 through 378. That way I'll be here to help you with questions. We've still got just a few more minutes. Go ahead and turn your attention to page 377. Actually, go ahead and turn to page 375. Look at example 6. 375, example 6. I've got a figure there, and it's a whole bunch of shapes put together, right? Basically, I've got a tent or some kind of building, or I guess it's a roof.
Yeah.
It's just a funny shaped roof. Okay. And they're saying I need to find the area of that roof. Because that roof is not a specific one shaped thing, I have to break it into multiple shapes. So I can see that each of my tops, notice that I've got, I've got tops, I've got sides. And so we can see where they've broken it into. I've got parallelograms. And what shape do I have on the sides where side J is? What kind of shape is side J?
Triangle.
It's a triangle. Okay, so I know if that side's a triangle, what's going to be the opposite side that we can't see? A triangle. So I've got to find the area of those two triangles. I have to find the area of side G. And remember, if I've got side G that is that area, then I know I've got an opposite side that's going to be the same area. What kind of shape is G? Side G, what shape is that? It's a trapezoid. Okay, so we've just said that I've got two triangles, and now I've got, that's a trapezoid. What is side H? What shape is H? It's a trapezoid also. What is K? Another trapezoid. So in this one, I'm actually having to find trapezoids G, H, and K, and triangle J. So if I find the area of those four sides, all I'm going to do is add the areas together to get the area of the entire group. That is going to be what we'll start out with tomorrow, is working with example 6, because that is going to help you with numbers 35 through 38 on page 377. All right, we have one more day until we are out for Christmas. I'm assuming you guys saw the email that when we return in spring, that the first couple of weeks we are virtual, completely virtual, but then after the 18th I think is Martin Luther King Day. When we return after the 18th, we are in person for the rest of the year. That is the plan.
Wow. that's crazy.
So hopefully we'll feel a little more settled once we get back after Christmas. The bell doesn't ring for another 5 minutes, so you got a couple of minutes before. All right, so in class work tomorrow. Let me know if you have any questions, and I will see you tomorrow. All
Yes, ma'am. Thank you.
right, you're welcome, hon.
Bye.
Bye-bye.
You're gonna wait for our biology class. People who are in biology.